We're going to talk now about a couple of different topics. The first one is the interior and exterior angles of a triangle. All right, first of all, you have a triangle ABC, all right, in the red. And we know, of course, that the angle A here, this angle right here, this angle, angle B, and angle C, we call them the interior angles, or on the inside of the triangle. Well, it turns out that triangles, we can also think of triangles as having exterior angles. If we just extend the line, the side, we make a little angle there. We extend the other side, another angle, and another one. And we call those, angle 1, 2, and 3, they're exterior angles. Okay, well, it turns out that A and C, we're going to call them remote because they're far away when you think about angle 1. Okay, so angle A and C are remote interior angles to angle 1. We could think of angle A and B being remote interior angles to angle 3. And the same thing for angle 2. Angle C and B are remote interior from angle 2. And as we talked about before, angle B plus angle 1, this angle B right here, wherever this measure is, plus that angle 1, they lie on a line, on a straight line, and a straight line is 180 degrees. So these two angles have to equal 180 degrees. We also know that this angle B, angle A, B, and C all have to equal 180 degrees, okay, because it's the sum of the angles of a triangle. So if we get rid of angle B, if we take away B from both of these, then, because they're both equal, I probably should put this in here. So we know that therefore angle B plus angle 1 is equal to this, since they're both equal to 180, this equals this. So angle B plus angle A plus angle C equals angle B plus angle 1. Well, if we think about this as being an equation, we can subtract angle B from both sides. So we're left with angle 1 has to equal whatever angle 1 plus angle C are. And that's why we can say that the sum of the two remote interior angles, angle A and C, are equal to the measure of the exterior angle, angle 1. Okay, let's do some practical problems with that. Okay, so suppose we're just going to find the unknown, wherever the unknown, the x or the question mark is. Here, these are the two remote interior angles to that question mark angle. Okay, so what should we do? We have to add 28 plus 58 because that's what that is. That's the sum of those two. So 28 plus 58 is equal to 86. So that equals 86 degrees. This one, they gave us the remote exterior, and we have to find the other interior. So in this case, we would have to subtract 110 minus 80 would give us 30 degrees. So that's 30 degrees. This one, the same thing. So we have to go and subtract 140 minus 45, and that, of course, is going to give us 95. We have to do all the barring and everything, but you get 95 degrees. So this one's 95 degrees. Did I do that right? Yeah, 95 degrees. Okay, so the next one now, that's not right. It's 85 degrees. 10 is 5. 13 minus 4 is 9. So it's 95 degrees. Because 95, 90 is, we can go ahead and check ourselves. 95 plus 45, that's 10, and that's 140. Yes, so we're right. Okay, it's 95 degrees. Now this one, we got some algebra in here. So we have to put this plus this is equal to that. So let's go ahead and solve for that. 11x plus 2 is equal to 5x plus 10 plus the 58 degrees. All right, so remember how to do these kind of problems. Let's combine our like terms if we can. We can combine the 10, the plus 10, the plus 58. So we really have 5x plus 68 is equal to 11x plus 2. So now we can draw our line. I'm going to subtract 2 here just so I don't get a bunch of negatives. So that's going to be 0. So we have 11x equals 5x, and 68 minus 2 is 66. Then I'm going to subtract the 5x to the other side. That equals 0. So I got 66 equals 11 minus 5 is 6x. So we go over here and divide by 6, and x equals 11. So here's the thing. If they asked us just for x, our answer would be 11. But if they asked us for, maybe they said this is angle A, asked us for the measure of angle A, we'd have to plug 11 back into there and get 55 plus 10. That would be 65 degrees. Okay? All right, next one. Similarly, same thing. I got to add these together. So this is going to be 30 plus 10x minus 10 is equal to 12x minus 4. Combine the like terms, that's going to be 20 plus 10x is equal to 12x minus 4. We can draw our line. Let's get the 4 over here and the 10 over there. That's a 10. So I'm going to add 4. That's 24. If I can do it all in one step, subtract the 10, that'd be 2x. So x equals 12. And again, we have to plug it back in if they asked us for a certain angle measure. Okay, now we're going to do another topic. introduce another topic for you, and it's called parallel lines. Okay, a couple definitions first. Parallel lines are lines in the same plane that do not intersect. You probably already know this. All right, so now we're going to learn a new word called transversal. A transversal is a line that intersects two or more lines. So when I have a transversal, I have two parallel lines here, so I'm going to go ahead and use black so I have a contrasting color. And if I just draw a line, it doesn't matter, it could be any line. That's not very straight, but just use your imagination. Pretend it's a straight line. That line is a transversal. It cuts through those two parallel lines. Okay, we kind of know this already, but I just want to review it. Congruent angles are angles with the same measure, and this is the symbol we use for congruent. Equal sign with a little similar sign there. And a conjecture, because this is what we're going to be doing. We're going to be making conjectures, and a conjecture is a conclusion based on something observed. So if you keep on observing something, you draw a conclusion. This girl is smart because she studies all the time. You observe her studying, so you know she must be smart. Or this girl must like red because every day she wears red, or something like that. You base it on your observations. Okay. All right. Now let's do some examples. Let's do a couple more. Let's learn a couple things. When you have remember this orange would be the transversal, and these are my black lines are the parallel lines. Well, when you do that, you create 8 angles. More than 8, but we're just going to talk about the 8 here. And we went ahead and numbered them. So let's talk about it first. We call angle 1 and angle 5 corresponding, because if you think about it, if you could cut this out and put it on top of here, it would be congruent. It would match. They would coincide. They'd be exactly laying on top. So we call angle 1 and angle 5 corresponding. As a matter of fact, they are also equal to each other. So actually angle 1 does equal angle 5, the measure of angle 1, equals the measure of angle 5. Let's figure out what else could be corresponding. Well, when I cut this out and put it on top of here, angle 2 matches angle 6. So those are corresponding. Angle 4 matches angle 8. They're corresponding. Angle 3 matches angle 7. So those are corresponding. So if you cut it out and it's in the same position, then they're corresponding. 1 and 5, 4 and 8, 2 and 6, 3 and 7. We call them corresponding. Okay, a couple other names we have for these angles. We call 3 and 5, they're sort of on the other side of the transversal, so we call that alternate. And they're on the inside. If you think about this as being the inside part of this particular figure we have, and these angles are on the outside, these 4 on the inside. So 3 and 5, they're alternate because they're on the opposite side of the transversal, but they're also inside the parallel lines. We call them alternate interior angles. Also then 4 and 6 would be called alternate interior angles. Okay? And the last set we have are exactly what you're probably thinking, alternate exterior, where I did the interior. So forget about these 4 inside. Now we have these 4 on the outside. So 1 is going to be the alternate exterior to 7. So 1 and 7 are alternate exterior. And so also we would have 2 would be alternate exterior to 8, to angle 8. Okay? So now let's go ahead and just talk about what we do know about some of these. We know that a pair of vertical angles would be 1 and angle 3. Also 2 and angle 4. Also, I don't have enough room, 5 and 7 are vertical, right, because they're opposite, and so are 8 and angle 6. Okay, let's talk about supplementary. We've got a whole bunch of those. Well, angle 1 is supplementary with angle 2. Angle 2 is supplementary to angle 3. Okay, I guess I could put and here. Angle 3 is supplementary to angle 4. So angle 3 and 4 are supplementary. So 1 and 2, 2 and 3, 3 and 4. 1 and 4 are also supplementary. Angle 1 and angle 4. Angle 5 and 6. Angle 6 and 7. Right, all the consecutive ones. Angle 7 and angle 8. And then, of course, angle 5 and angle 8. They're also supplementary. So supplementary meaning they equal 180 degrees. Okay, let's see what else we can do here and not topple over. Okay, so we also know some things now. We know that the measure of angle 1 and 3 are equal because they're vertical. We know that also 5 and 7 are equal because they're vertical. We also know that 1 and 5 are equal because they would correspond with each other. So that means that all these angles, 1, 3, 5, and 7, are all equal to each other. That is cool because once you get the measures, like if I say angle 1 is, say, oh, I don't know, 50 degrees. Guess who else is 50 degrees? Angle 3 is 50 degrees, angle 5 is 50 degrees, and angle 7 is 50 degrees. All those guys are 50 degrees. And you can know, if that's 50, what's 2? What's angle 2? Angle 2 has to be 130 because it has to equal 180. And same thing, angle 2 is equal to angle 4, 6 is equal to angle 8, and because they're corresponding, 2, 4, 6, and 8 are all equal to each other. And they're supplementary to the other guys. So it's all connected. It's really going to be fun. So we talked about that right there, how they all equal 180 degrees. I don't think we need to go into that. But like 1 and 2 equal 180, 2 and 3. And we kind of see that by the measurements there. All right, last one. Just going to work out a couple problems now. Okay, here's some examples. Okay, number 1. Well, these are corresponding. You can tell by their position. So we know that those two then are equal. So 53 equals x. Easy as pie. That's what x equals. We figured it out. These are alternate interior. And they are also equal because if you think about it, this x corresponds with this angle down here, but that's vertical to that one, and that one's equal. So x equals 113. And we'll do more examples of this in class if you don't quite get it the first time. Okay, this got scratched away, but I think I can see what it is. This looks like it's 3x plus 10, and this is 4x minus 8. And this is what kind of angles? They're corresponding, so they're going to be equal to each other. So this you have to work a little bit for. 3x plus 10 has to equal 4x minus 8. You can draw your line. I'm going to add the 8 here, 18. At the same time, I'm going to subtract the 3. 18 equals x. There you go. Okay, these are also corresponding, so they'd be equal to each other. So 75 is equal to 11x minus 2. Draw my line, add the 2. It's 77 equals 11x. X equals 7. Okay, now these are alternate exteriors. Let's see if they're equal to each other. Well, I know this guy equals that guy. I know if we took this and we placed on top of here, this angle right here, whatever this angle is, I'll put a little dot there, would sit on top of this one. So they must be equal to each other. So I've got negative 1 plus 14x equals 12x plus 17. So I need to get my guys together. I'm going to add the 1 here and subtract the 12 there. So if I add 1, that's 18. If I subtract 12, that's 2x. So x is going to equal 9. And again, if they ask us for the actual angle measures, you have to take that 9, plug it back into whatever angle they want us to find, and find the angle measure. Okay, we'll do more in class. Don't be discouraged. It looks like a lot, but it really flows very, very easily, and it becomes very, very simple.